So I'd like to do a bit of a video discussing the essay requirements because I had a number of questions about this. The essay requires students to evaluate a topic that we have studied in the course. Now, in this context, evaluation means to critically examine information and make judgments about a topic. It's one of the highest levels of thinking that can be expected of undergraduate university students. So on the screen's a picture of Bloom's taxonomy, which shows roughly four levels of cognitive skills required at the undergraduate level. So on the bottom, you've got remembering, recalling, or finding facts. Then you've got understanding, which is the ability to comprehend information and, for example, process that information into summaries, like we've been doing in some of our classes. Applying means to take extra existing information and put it into some different but similar form. So, for example, in the quantitative classes, we've been applying formulae. So we might take the dispersion relation formula to answer questions about speeds of linear water waves in shallow water. If we're applying that dispersion relation formula, however, you've got to understand when it can be used. And then you also have, and in order to understand it, you have to remember that it exists in the first place. So all of these things build up on each other, and this course builds on this pyramid, if you like, right? So the peak evaluation, the highest level that we're going to be thinking about here, builds upon application, understanding, and recall. An evaluation in the context of waves and fluids must include recalling information, understanding the recalled information when it's relevant, the conditions under which it can be applied, and that's usually based on the assumptions that are made to get that information, whatever it might be. Then in the analysis step, you've got to apply that knowledge, information, formula, whatever. You've got to analyze the result, right? This is what really evaluation means. It's making a critical judgment. You're taking something and you're comparing it with expectations, right? You might set yourself up to have an expectation of something. Um, you might compare with other observations in nature or similar phenomenon or other similar things that you are comparing against, right? You examining a bunch of information and you're making a judgment. So let's just consider an example topic that we might want to evaluate. And let's say that this is the use of the KdV equation to model rogue ocean waves. We can set out an evaluation as follows. We need to find and recall all of the relevant information, such as what is the KdV equation, what's a rogue wave, what is the ocean. We need to understand this information. We need to understand why it's important. How does the KdV equation relate to ocean waves? What's the KdV equation fundamentally predict about the waves? What kinds of solutions are possible? We can then apply the KdV equation to our problem. And it's important to note that somebody else has already done this. We're not doing novel research in this essay. We're not generating new knowledge. Application in our case means describing how the KdV equation, which you've seen in some context, is used for modeling rogue waves in another context. We can then finally conduct our evaluation. Based on the information we've collected, considered, we can determine that if modeling rogue waves with the KdV equation is scientifically appropriate and what utility that model may have. How do we present this evaluation? We're going to use the traditional Western literature structure known as the three-act play. I've got a slide here that tells us what the three-act play looks like, and this is for movies, right? So the structure is used in many popular movies, Star Wars, The Matrix, all of the Marvel movies kind of follow this general formula. What we're going to do is we're not going to look at, obstacles and disasters and crises and so on. We're going to think of Act 1 as being an introduction or an exposition. We're setting up all background information and motivation for our evaluation. So that is, why do we want to study something, right? We want to explain that in our introduction, right? It's got to be, we've got to compel the reader to be interested in our evaluation. Um, we need some broad background, like what's a fluid, what's the ocean kind of thing. This is where you answer that there. Uh, Towards the end of the first act, and roughly what is equivalent to the inciting incident or the dramatic question, dramatic point, you present the thesis of the essay, the main point. It can be presented as a question. In fact, I usually like presenting it as a question, but that's not actually necessary. Um, Going back to our KdV equation example, it might be, can we use the KdV equation to model rogue waves? Right? It has a very obvious yes/no answer. So Act 2, the ascending action, it's called the confrontation or rising action in movies, and we're not going to have a big twist in the middle. It's just going to be a series of points that you need to answer your thesis, right? Um, think of this as being, the Rocky training montage, for example. You're expanding on specific details required to support the thesis. So, for example, KdV equation for rogue waves, we might outline the derivation and solution of the KdV equations. We might talk about the condition for rogue wave formation, propagation. Um, the section requires both understanding because you're filtering and summarizing relevant information, and application because you're taking that information often from different contexts and you're applying it to your particular case. Most of the essays in this course will address some complicated real-world problem by comparing back to idealized fluid dynamics, simplified behavior. We did this with linearized water waves, right? We've got water waves. We're thinking about waves in the ocean, which is a three-dimensional, very complicated problem where we've got stratification, we've got salinity, we've got different obstacles. The ocean is not a nice rectangular basin. And we idealized it to two dimensions with a small ripple on top, right? Like that's how we did this that's what we studied. And we will be comparing complicated dynamics to some idealized study. The assumptions underpinning that idealization must be carefully discussed, and you've got to say when the assumptions are valid or not, right? Because that's how you're applying your information in your new context. Once you've got all of this information together, and it's got to be complete, right? You've got to have a set of all the relevant information to address your question. You draw your conclusion, right? That is the climax of Act 2. It's often considered if you like, the climax of the film or the resolution point. So it might be, the Death Star blowing up in the first Star Wars movie. So that's your conclusion is addressing or supporting, rejecting your thesis, the main question from the beginning of the essay. Then you've got all this other stuff, right? You've got what's called the resolution or denouement or descending action in the diagram on the slide. You're talking about the consequences of the climax, right? You might discuss alternative views, like you might here is where you would put alternative models other than the KdV equation for rogue waves. For example, you might use shallow water equations, but that might not always be relevant. You might compare what your model predicts to similar predictions. You might take, behavior in a wave tank and compare it to behavior that you've observed in a tsunami. You might consider how you might extend the thesis entirely, right? So you might go, well, if I can use the KdV equation to model rogue ocean waves, what else can I do with it? Can I use it to model, the interaction of these rogue waves, for example? You might also use the end of your essay to discuss benefits or costs of adapting proposed solutions, right? So how good is the model that the KdV equation provides? Is it useful for weather prediction? Can you use it for tsunami warning, for example? Is this going to help people who might live in areas that are at risk of inundation from rogue waves? What can you tell ships? You can also look at the limitations and you can discuss what might be required to answer the question or solve the problem better, right? You can talk about further extensions. So that's the structure that your essay should kind of follow. And how it will be marked is by comparison to a rubric. So a rubric such as, but not exactly, this one. This is a general rubric on which I base the specific ones that I need, right? So each assessment item is supposed to have a specific rubric. I found this general one and then I use it to generate all the others. So the rubric is designed so that getting a passing mark in this essay should be reasonably straightforward by basically following the guidelines, right? If you go and write something that, addresses a topic that you've studied from the textbook and it includes a bit of an evaluation, you're gonna pass, right? It's that the satisfactory is that you've grasped the underlying concepts and materials, you're able to use most of the techniques that you've taught, and you're able to present your solutions in a clear enough way that I can see that you understand, right? So that's really you might attempt an evaluation and you might only really thoroughly demonstrate understanding on that taxonomy, but that's still enough to get you a pass. The rubric's also designed such that getting an HD is really hard. If you look at the excellent on this general rubric, you see it's mastery of advanced techniques beyond what was explicitly taught. That is that you've digested the textbook and you've gone out and you've processed it yourself, you've collected other information from other sources, and you've put that information together, and you've demonstrated that you understand the information well enough to do that. You demonstrate that you can apply new information, and you've synthesized all of the ideas across the subject, and you've provided a critical analysis of your question, right? You've really gone and thoroughly considered all the pros and cons of using the KdV equation to model rogue waves, for example. Right. The distinction is also, right, you're comprehending and synthesizing information beyond the bounds of the course. You're presenting your solutions well and so on. Now, this doesn't mean that you're going to get a distinction simply because you take a different reference and put the information in. You really have to demonstrate that critical analysis and judgment, right? You've got to be able to process the information thoroughly and produce a well-argued judgment and well-argued evaluation. And you see it going down into the credit levels. It's dropping off the amount by which it's dropping, firstly, the knowledge and the ability to use techniques, and it's looking to just check or see that you've got evidence of stuff beyond what's taught, right? So you've been able to, think about all the material that you've been shown and put different bits of it together, right? That's sort of where you're getting to with credit level, but you're still able to, put some sort of judgment out there. What typically happens in previous iterations of the course, a lot of the essays tended to be recollections and demonstrations that they understand what they've been shown. The students demonstrate they understand what they've been shown, but they would struggle to apply the information. It was often difficult to see the relevance of certain information in the essay, either by, including information that wasn't particularly relevant or omitting information that was quite relevant. So a lot of the times that you mark student essays, it's getting that judgment and a thoroughly justified evaluation. Um, it was students were often struggling to do that, but that's roughly what's expected at the undergraduate level. Most of the students, if not all of the students, I've never had anyone fail the iterations of this course. The the students would be able to grasp, understand, and demonstrate a level of comprehension somewhere around the superior, satisfactory, and superior levels. Occasionally, you'd see an unsatisfactory essay, but the rest of the marks throughout the course boosted them up to a pass. So, some people might produce a bad essay, and that's certainly happened, and it's really an incomplete essay. That's where you tend to find yourself in the unsatisfactory band for the essay. Most students are able to grasp the material at satisfactory and superior level. A few students will be able to demonstrate the synthesis of material into critical analysis and judgment, or outstanding critical analysis and judgment. So I hope that helps describe what the essay is looking for, how to, in terms of the knowledge that you're expected to demonstrate, the um, the structure of the essay, how to put it together, and a general rough guide as to how it's going to be marked. When the essay question is released, it will come with a proper rubric. It will come with a essay on KdV equations for modeling ocean and atmospheric waves, because that's what I've decided to do as an example. That way, you've got an example essay. It'll be marked, or it'll have commentary on it to tell you, what's going on with it, and where it would sit in relative to the rubric. So you've got an example to follow, but you don't have an example to copy, right? So you've got something that's not one of the questions that's going to be asked. Like, we didn't really spend time studying the KdV equation. We briefly encountered it a couple of weeks ago, but you'll have an example that shows you how to write the essay on your chosen topic.